Dear friends of computer science students, welcome back to Computer Guru Weekends computer classes. In this module, we are going to learn about ML Ops. ML Ops means machine learning operations. It is a set of practices, tools, and processes that combines machine learning, development ops, and data engineering to automate and manage the entire life cycle of machine learning models, from development to deployment, monitoring, and continuous improvement. In simple terms, ML ops is a machine learning what DevOps is to software development. It helps continuous It helps organizations build, deploy, monitor, and maintain AI models efficiently, reliably, and at scale. Let us see through this sketch how it works. First, we start from artificial intelligence, then we go to machine learning, then we go to deep learning, then we go to large language models, LLMs. Then we go to generative AI. So machine learning operation life cycle is completed. Ecosystem is sketched here. It deploys, manages, monitors, and maintains ML AI systems. We will learn through real-world example of working of ML ops. The first case we are going to discuss is fraud detection in banking. One, millions of transactions are collected daily. Second, data is cleaned and validated. Third, a fraud detection model is trained. Fourth, the model is evaluated and stored in registry. Fifth, it is deployed as a real-time API, application programming interface. Sixth, incoming transactions are scored instantly. Seventh, monitors detects if fraud pattern change. That is known as model drift. Eighth, the model is retrained with new data and deployed automatically. Dear friends, now on to benefits of M, M, MLOps, machine learning operations. One, faster deployment of AI models. Second benefit is better collaboration between data scientists and engineers. Third benefit is improved reproducibility. Fourth is automatic training, retraining. Fifth, better governance and compliance. Sixth, easier scaling. Seventh, lower operational costs. Eighth, more reliable AI systems. On challenges side is managing large data sets, model drift over time, data quality issues are the challenge, complex deployment pipelines. Fifth, security and privacy concerns. Sixth is cost of infrastructure. Seventh, coordinating cross-functional teams. Dear friends, skills needed for MLOps. One is you have to learn Python programming. Second, machine learning fundamentals, data engineering, SQL, GIT, Git, then Linux, Docker, Kubernetes, cloud computing, CI/CD pipelines, monitoring and observability. Friends, adopting an MLOps practices takes away the tedious manual labor involved in looking after a machine learning model while ensuring ongoing performance and reliability. By streamlining collaboration between different teams and MLOps practices foster agile development and data-driven decision-making within organizations. Now, what are the common tools or platforms for working on machine learning operations? Common machine learning operation tool include both open source framework and cloud platforms. For instance, Kubeflow and MLflow help manage ML pipelines. Docker and Kubernetes are used to containerize and deploy ML services. And cloud platform like Amazon, Segmenter, Maker, Google Cloud Vertex AI, or Azure ML Studio for integrating ML operation solutions. These tools help automate training, deployment, and monitoring of models at scale. Red Hat OpenShift includes key capabilities to enable machine learning operations in a consistent manner across data centers, public cloud computing, and edge computing. Dear friends, Special Interest Group SIG defines machine learning operation as an optimal machine learning operation experience as one where machine learning assets are treated consistently with all other software assets within a CI/CD environment. Machine learning models can be deployed alongside these services that wrap them and services that consume them as part of a unified release process. CI public CD stands for CI means continuous integration and CD means continuous delivery or continuous deployment. A CI public CD pipeline is an automated workflow that builds, tests, and deploys software whenever changes are made to the source code. It is a core practice in development operations and is also widely used in machine learning operations for deploying machine learning models. Uh, Dear friends, this diagram describes the machine learning operation. Machine learning operation equal to machine learning plus development, thus and plus operations, machine learning, development, and operations. Uh, you start with data, then develop test feature pipeline, then go to development model, then train, validate model, fifth deploy monitor. So data operations starts from CI public CD platform. Then data goes to machine learning operations and model repo service and monitoring are generated through Git code. Dear friends, to adopt machine learning operation, we see three levels of automation, starting from the initial level with manual model training and deployment, up to running both machine learning and CI/CD pipeline automatically. First, manual process. This is a typical data science process which is performed at the beginning of implementing machine learning. This level has an experimental and iterative nature. Even every step in each pipeline, such as data preparation and validation, model training and testing, are executed manually. The common way to process is to use rapid application development tools such as Jupyter or notebooks. Second, machine learning pipeline automation. The next level includes the execution of model training automatically. We introduce here the continuous training of model. Whenever new data is available, the process of model training is triggered. This level of automation also includes data and model validation steps. And third, CI/CD pipeline automation. In the final stage, we introduce a CI/CD system to perform fast and reliable machine learning model deployments in product. The core difference from the previous step is that we now automatically build, test, and deploy the data, machine learning model, and the machine learning training pipeline components. The picture in next slide shows the automated machine learning pipeline with CI/CD routines.